Hi guys, welcome back to the course. In the last video we learned about GTK container, which has this limitation to have only one widget at a time. So in this video I'm going to introduce you with a new GTK layout container, which is GTK Box, which can have multiple widgets. So let's roll the intro and then get started. Alright, so in the beginning of this course I told you we will be following this documentation, but I noticed that this look and feel is now changed to like this. And if you want to search for something, let's say container, so you can type right here GTK container and you will find every relative result. But I'm not very impressed with this kind of documentation, so I found another website which provide the same old school GTK documentation. So this is a GTK 3 referral manual, and it somehow looked like the old school documentation. So I will ping this link in this video's description box so you can refer from here. So the container I was talking about, this layout containers, and here we have the first GTK box. So let's open this in a new tab, and here we have everything very well organized. These are the functions which we use for GTK box. This is to create a new box, this is to pack the widgets at the start, at the end, and many functions are there. Yeah, without further ado, let's open our terminal and dive into the GTK tutorial directory, and we have these many files till now. And let's make a copy of our container.c file and name it as box.c. Perfect. Now let's open this box.c. So basically the idea is we can put only one widget inside GTK container, which is nothing but our GTK window. So we will create a GTK box and put that GTK box inside the GTK window container. And that's how we will achieve our goal to place multiple widgets in a single window. So let's create a new widget here, which is GTK widget. Let's name it box, and now let's define this box here. The box is equals to GTK box new, and this function required two arguments. The first is the orientation. We have two orientation, GTK orientation horizontal and GTK orientation vertical. So if we follow the documentation, we have these here. So let's first use the horizontal one. It will place your box as the horizontal. So here we have, and the second is the space between your child widgets. So for now I will put 0 because we can override this property when we are packing our new child widgets. So not an issue, we can put it 0. Now we need button 1, button 2. Here we are adding button 1 into the container. We do not require that. We can remove button 1 and put our box. So basically I'm putting my box widget inside the container, and I will placing button 1 and button 2 widget inside the box. We do not require to add button 1 into the container and button 2. Okay, so I comment this. Alright, so by now I have two buttons, a box and a window. So what we are left with? So we have to put button 1 inside the box container. So the function used here will be GTK box pack start. The start mean it will start packing your widgets from the beginning of the container, and the same function is for like end. So this function will pack your widget at the end of the container. So let's first see what start do. So first we have to pass our GTK box. So let's typecast our box into GTK box, so to avoid warnings. And then you have to place your child widget. So the child widget is button 1. Perfect. Now the next two arguments are of Boolean type. The first is the expand, which means you want to expand your child widgets with respect to the parent box. So yes, I want that. And the next is fill. So if we put true for fill also, then it will fill out the space on increasing the size of the parent window. Also note one more thing, if you put expand as false, then this fill has no effect. So let's make it true once again, and we will experiment on this later. And yes, the last argument is the padding, which I was talking about earlier. Here you can override this spacing property. So let's give the padding here only, and the padding will be, let's say, 50. And we can do the same for our next widget, which is button 2. So I'm adding 2 widgets inside my box, and the rest of the arguments will be same, not an issue. Perfect. Now our code is ready, or we can remove these comments. All right, so let's open a new tab and open our make file. Here we have to replace the name container with the box because our program name is box now. And now we can run the make command. Perfect. No errors and no warnings. And we can run this box here. Remember, we put our box as horizontal, so it is more in width. If I put it as vertical, you will see a more height. And we have set the expand property to true and fill property also as true. So if I expand my parent window, it will expand these child widgets too. Now the code is ready, so we can make some experiments. Let's try the second orientation, which is GTK orientation vertical. Let's save it, make it again, and run the box. Perfect. Here you see now the height is relatively more than the width because the box is vertical. And here the expand property is still true, so expand and fill are perfectly working. Now let's try if we put expand as true and fill as false, what will happen? Let's try here. I'm making fill false for the button 2. So notice, let's run make command. My bad. Alright, so I made a typo. Run make and run the box. Yes, no change in the first view, but the moment you expand this, you will see the button 1 is also filling the space, but button 2 is not. It's still expanding, but it's not filling the space. Alright, so we have getter functions also for GTK Box, and let's say we'll declare a new variable which is homo, and this getter function will return true or false. True if the GTK box is set to homo, and false in case it is not. Homo mean here all the widget inside the box, basically all the child widgets inside the GTK box are of same size or not. So homo property set the child widget size to same. So the query function will be GTK box get homogeneous. Alright, so it require only one argument, which is GTK box, and just to avoid warning, let's type cast into GTK box, and we can use our printf function to print the returned value. it will be 1 if the homo property is set to true. It will be 0 if the property is set to false. So we can put our message like is homogeneous question mark, and let's say mod d to print integer value, and here I will print is homo. Alright, so let's make this file once again and run box. So you see is homo is set to 0 because we haven't set the homogeneous property till yet. So let's break it, and now we have a setter function to set this homogeneous property, which is quite the same. So I can yank it and paste it here, GTK box set homogeneous, and we have to pass this GTK box and the value as true. So we are setting homogeneous as true. So if I try to read this property from the getter function, it should be true this time or 1 this time. Is homogeneous after setter call. Alright, so just to differentiate between this print and this print. Make this file again, run the box, and yes, is homogeneous, it's 0, which means it is not, and is homogeneous after setter call, it returned 1, so that means now these buttons are homogeneous and will be of same size. But we have set fill property as false, that's why it's not increasing its size. Alright, let me show you one more GTK widget function, which is GTK widget set size request, and we will be setting the size of button 1, GTK widget set size request, and it required 3 arguments. The first is GTK widget, so the widget here is button 1. Second property is the width. Let's say I want width as 500 and height also as 500. So let's save this, and the expected output is if the size of button 1 is 500 into 500, the button size 2 will also be 500 into 500. So let's make it and run the box one more time. We have to set that fill value as true. Now let's try one more time, make it. Alright, once again. And yes, you can see (300 into 300). Yeah, now it's more visible, the button 1 and button 2. We can do one final thing here, which is to check out our GTK box back end function. So if you notice, if I run the box one more time, you will see the button 1 is at the start and button 2 is right after that. It is happening because GTK box first packed the button 1 and then packed the button 2 at the start. But let's say if I want to pack my button 1 at the end and button 2 at the start, so the expected output will be button 2 will be at the start of the container and button 1 will be at the end of the container. So let's make this file one more time and run box. Yes, so you see button 2 right here, it is packed at the start of the container, and button 1 is right here at the end of the box container. Alright guys, we see here GTK Box solve our issue to add multiple widgets inside one single window. But here we see we have no control of the positions of these widgets. So in the next video, I will be telling you one more GTK layout container, which is GTK fixed, which allow us to set the exact location of our widgets. So that's all for this video. Like this video, share with your friends, and tell them how you can create GUI applications using C programming language. And yeah, do subscribe to Educators. Thank you and bye bye.